But what does it mean to test EF Core? From my experience, it could mean three things. First, it could mean that you want to make sure that the way you defined your DB context works with the database as you expected. That would mean writing tests that use the DB context directly and verifying some results. Did the database return the primary key of a newly inserted record, for example? Do queries with includes bring back graphs of data as expected? Another way of testing EF Core is ensuring that it responds to business logic that makes calls to your DB context. This doesn't necessarily mean something needs to happen in the database. Earlier in this course, for example, I showed you how the context tracks entities, and we looked inside the change tracker property of the context. Perhaps you're inserting a graph of data and want to be sure that the context has set the state correctly on each element of the graph. You can verify the context change tracker without needing to call save changes to persist all the way to the database. However, you may have methods that track an entity and call save changes in the same method. If you want to write a test that doesn't require hitting the database, you'd then have to split that logic into two methods, and that may turn out to be a great solution. Or you could run the method to test the full workflow from your business logic to EF Core to the database and back. But sometimes hitting the database when testing is really undesirable. It could slow things down, or what if the database isn't there? The test doesn't really care about that, but that would impact the test. One of the most important things you'll learn in this module is how to avoid hitting the database in those types of scenarios. And you do that using a different EF Core provider during the test, and that's called the in-memory provider. So that's a pretty high-level introduction, but because this is a Getting Started course, I didn't want to assume you came here with that knowledge. This should be enough for you to work through the rest of this module and truly benefit from what I'll be sharing with you. First, we need to prepare the DB context to be flexible enough to use a different database as needed. I've returned to the console solution where we left off at the end of the module about using raw SQL. And this is the solution where the SQL Server provider and connection string are hard-coded into the pub context on configuring method. But there are a few important changes I've made to the pub context, which you should see before we get started. The first is giving me the option to predefine the connection string before the app hits the onConfiguring method. Now I'll take advantage of the option builder's isConfigured property. If it's been pre-configured, I don't want to apply any of this logic. But if it's not pre-configured, as I'm checking here, then go ahead and configure it with a hard-coded connection string and logging info. You've already seen an example of pre-configuring, which I did in the ASP.NET Core app. And that means the DB context needs a constructor that lets me pass in the options. So like the one we created in the ASP.NET Core app, I'll add that same constructor here. However, I still do want the option of just instantiating the pub context without pre-configuring those options. So I've also added an explicit empty constructor. This way, when we add a test, we can design the test to pre-configure those options and pass them into the context. Otherwise, if we're just running the program, it will use the hard-coded information. And as a reminder, the only reason it's hard-coded here is because it's a demo. But in your real-world applications, I would recommend always configuring the provider and the connection outside of the DB context class. In order to run tests, we'll need a test project, and we can use another project template here. I'll filter on Test and select MS Test Project, which uses .NET Core's testing framework called MS Test. I'll name my test project Pub App Test and choose .NET 6.0 as the target framework and click Create. The template gave the project a bunch of packages referenced for testing, but we also need to add in references to the data and domain projects. And in some cases, you may not be using EF Core directly in the tests, but we will be for the work that we're about to do. So I'm also adding a reference to the EF Core SQL Server package. This first test we're building will be an integration test, and we'll use it to verify that the pub context we defined, integrates as expected with EF Core and a SQL Server database. Next, I'll rename the new test class to Database Tests. And this method, which is a test, I'll rename that according to what it is that I want to test out, which is ensuring that when I ask Entity Framework to insert an author into the database, that it truly performs that action. So I've named the method CanInsertAuthor into database. I've pasted in the test code and added using statements for the data and domain namespaces. You can find all that code in the download, so you don't have to type it out. And I want to point out that for the purpose of what I want you to see in this demo, this is a more involved test than how you would typically write a test. So what is this test doing? First, I'm predefining a DB Context Options Builder. This builder uses the SQL Server provider, but it points to a different database than the one where all of our nice sample data lives. It's called pub test data. Next, I'm instantiating the pub context and passing in not just this builder, but the builder's options property. Remember, it's the options that the new constructor is expecting. Then I'm calling database ensure deleted followed by ensure created to be sure that I'm working with a fresh database every single time. That way, I have a control factor over knowing exactly what is or isn't in the database as I'm getting started. And this is why it was important to point out the connection string to a version of the database specifically for these tests. Next, I instantiate a new author. And because I'm only testing that the author does make it into the database, I don't really care about the author's properties. But since first and last names are non-nullable, I'm just providing the minimal data for them. First name is A and last name is B. Next, I'm adding the new author to the context and then outputting a little bit of debug data, which is something that's not really normal for testing. But again, for the sake of this demo, I want you to see this stuff. What I'm outputting is what the ID of the author is before I call add, then I call save changes, and then I'll output the ID of the author after calling save changes so we can see what's going on there. Finally, the most important part of any test, it's assertion. What is it that I'm trying to prove with this test? Well, the test name says it all, that Entity Framework can insert an author into the database, which also shows that I set things up correctly in the DB context with respect to that particular app. And there are a few ways that I could prove that the author made it into the database. But here's the proof that I chose. Because I'm using a database that generates IDs, and part of Entity Framework Core's job when inserting is to receive that database's newly generated ID and apply it to the key property of the author. So what I'm going to do is make sure that that key value, the property named author ID, is no longer 0. In other words, some non-zero value has been assigned by the database and set to the property by EF Core after Save Changes was finished. Now I'll run this test. Visual Studio has a test runner built into it, and if you don't have it open, go to the Test menu and choose Test Explorer. By default, opening the Test Explorer will trigger the solution to build and look for any runnable tests. Drilling down into the project and the class, there's my test. I'll right-click on the test name and choose Run from the context menu and wait for the test to finish. It's normal for the very first run of a test to take a little longer, but it's done, and that green check mark is just what you want to see. It means all of the tests that you've run have passed. Otherwise, you would see a red circle with an X in it. That should be pretty obvious that there's a problem. It's nice that the test passed, but there's certainly more we can learn from its results. The output from the test is displayed in the test details summary. In fact, if I still had logging enabled, all of that would be in the output as well. So what the output tells me is that after I added the author to the context, its ID was 0. But then, after I called Save Changes, its ID was 7. But why 7 and not 1? That's because in the DB context, we still have the code that seeds the database with 6 authors. So the new value assigned by the database for this author was 7. That's all good, but there is something here that isn't wonderful. The test took almost 3 seconds to run. While EF Core is pretty quick at creating SQL Server databases, especially if you compare that to an older version of EF Core, if you're running a lot of tests, 2.9 seconds is a long time. So what can we do to bring that down? Interestingly, running it again is faster by a little bit, not counting the compile time for each run. Now it's 1.8 and 1.9 seconds, and that time seems to be consistent if I run it over and over. And I wouldn't normally output to the debugger from a test. That was just so that I could show you what's going on under the covers. But removing the write lines doesn't really make a difference. This is still 1.8 seconds. Deleting and recreating the database are definitely impacting the speed. I could remove these, which reduces the time even more. And for what it's worth, it's the same if I only remove ensure deleted. It's the effort of reading the data model, building up the SQL, and executing it on the database that's responsible for this bit of time, not deleting the database. And in fact, if the database does already exist, then ensure created won't have to do anything more after it checks for its existence. And this is saving about a half a second. But while I've gotten the time down from 2.9 seconds to 1.3 seconds, that's not really a win. I am not comfortable with skipping this database reset. I'm now in a situation where my test won't have a database in a known state to test against. And that was the goal of originally deleting and recreating the database each time. So I am going to add these back in, but this helps me make an important point. Sometimes you really need to test against the database, and it's just going to take longer. So with more testing experience, you can learn to be discriminating about when it's important to use the actual database and when it's not. In some cases, even though the production database might be SQL Server, you could switch to using a lighter weight database like SQLite for your tests. And again, that's if you really want tests that are truly running against the database and you're not doing performance tests, or running any code in your tests that's dependent on specific behavior of SQL Server. In other tests, database doesn't really even matter, and that's where we can use EF Core's in-memory database provider, which is what we'll do next.